Hey people, you're probably like, why is there so much crap on the screen? Um, don't fret. I'm just using the same same slides slide thing. I don't know what I'm trying to say as the last video. That's why. So now you can ignore the mess above and we'll focus on the clean stuff below. All right. So this is for Tuesday. We're going to do lesson 19. Essentially, we're still doing the same things we've been doing. We're solving equations and inequalities. We're going to specifically talk about rearranging formulas where there could be one variable, but oftentimes there are two or more variables, right? So instead of just x, we're going to have x and y, or x and a, or a, b, c, and x, right? So not just one variable this time, but multiple. All right. Hopefully you enjoy that meme. I know I did when I saw it. Okay. So that's what we're doing today. That's what the supplies you need: your notebooks, your eco books, pen or pencil, and calculator. Okay. So let's talk a second about formulas and why learn how to rearrange them? Formulas relating to or more variables or symbols show up in all sorts of areas in life, okay? Not just in math. Yes, they are obviously very prominent in math, but they also show up in science, psychology, physics, chemistry, um, tons of stuff, right? Tons of stuff. Biology. I was trying to think of biology. That's the word I was looking for. So you can see over on the side some of the more famous equations, right? I'm sure a lot of you have heard the equation E equals mc squared. Maybe you don't know what it is, but you've probably heard it before, right? That one's basically saying the faster you move, the heavier you get, right? Okay, so there's some, I wanted to just kind of show you some of the more prominent physics formulas that have more than one variable, right? So later on, when you take physics or biology or chemistry, you're going to see formulas like this, and you're not going to have to freak out because you're going to know now how to rearrange these formulas without too much trouble. Okay. So formulas can stand on their own as a relationship between variables, even without an applied setting. Okay. We use equation solving techniques, so things we've been talking about before, like distributive property, commutative associative property, or properties of equality. So like adding and subtracting or multiplying things on both sides of the equation to rearrange formulas and solve for specific variables. Okay. So, another common one that you've probably seen, I know you've definitely seen it in math because I remember going over it with you guys in 7th grade. The rate and time gives us distance, right? So there's 3 variables, but let's say we had the time and we had the distance, but we didn't have the rate, right? We would need to rearrange the formula to solve for r. So we don't need r times d times t equals d. We need it to look like r equals something, right? Or maybe we need to solve for time, right? We need to know how to rearrange those formulas to solve for specific variables. So that's what we're going to be looking at today. Okay. So let's look at exercise 1. I don't know, I was on like a meme roll for a hot second, and well, there you go. There's a High School Musical meme for you. We're gonna do this one together. We're all in it together. And yes, you're probably wondering why we're skipping a bunch of lessons. We're actually going to go back and do lessons 15 and 16 later this week. But we'll be skipping 17 and 18 altogether. Just telling you this while I'm getting to my lesson 19 page in my book. If you can hear pages slipping, that's why. Okay, so exercise 1, lesson 19. Hopefully you're opening up in your Eureka book to that. We're going to solve each equation for x in exercise 1. And again, we're going to do these together, mostly so I can point something out to you. So we're going to start with A. We have 2. That was a weird 2. It almost looks like upside down. 2x minus 6 equals 10. We want to solve the equation for x, so we need to rearrange this equation for x, isolating x on one side. So everything else, that negative 6 and the 2, need to be moved to the other side. So let's get rid of the 6 first. We do that by doing the inverse operation. Right now it's being subtracted, so we need to add. Remember, if you add to one side, you have to add to the other to keep the balance. And here we get negative 6 plus 6 would be 0. So we're left with 2x on the left. And on the right, we have 10 plus 6, which would be 16. Now all we have is our x being multiplied by 2. So to undo that multiplication, we would need to divide by 2 on both sides. And there we are left with 2 divided by 2 is 1, so x on the left, and 16 divided by 2 would give us 8. And voila, we have solved for x. We know our solution. Now we're going to do C, problem C. Okay, I'm going to do it side by side here. We have ax minus b equals c. And some of you may already know where I'm going with this, but we'll just keep going. So again, we need to isolate x. That means we need everything else, the negative b and the times a on the other side. We're going to start with getting rid of the subtraction first. So we have minus b, so we need to add b to move it. That would give us a times x equals, because a negative b plus b would be 0. Okay, and then c plus b, we can't combine those because they're not the same variable. So we would just simply write c plus b or b plus c. Either way is fine. Okay, so now we have a being multiplied by x, and that's the only thing happening to x now. So we need to divide to get rid of it, right? Do the opposite. It's being multiplied, so we divide. I don't know why I wrote 2. A divided by a would just be 1, so those cancel out. We're left with x on that side, and we have to divide on that side, and we are left with, and again, you cannot combine those, so we would just be left with c plus b, or again, you could write it b plus c, divided by a. And voila, we have solved for x. Now what I want to point out is the similarities of what we just did. Okay, so you'll notice our first step, we added something. Okay, our next step, we divided by something, and that isolated x. Okay, so while yes, there was only one variable over here, the rest were numbers that we could actually combine to simplify, right? The process was the exact same when we had just variables, right? So instead of one variable and 3 numbers, we had 4 variables altogether here. But our process was the exact same. We were still isolating for x, which means we still just basically had to move everything over to the other side. While it doesn't look as clean because we can't combine those since they're not the same variable, the process, again, was still the exact same. We added 6, we added b. We divided by 2, we divided by a, and that gave us x equals some quantity. Okay, so the process is the same. Whether there's one variable or multiple variables, it's the same. Okay, we're still isolating the one thing using inverse operations to do it. Okay. All right. Exercise 2. Basically that's just going over what we just did. So in your own words, I want you to answer that. Did you do anything different to solve for x in these two equations? Okay, so answer that in a full sentence. Then we'll move on to exercise 3. Okay, now you'll notice this is the same formula we just looked at, a times x minus b equals c. This time, though, we're solving for a. So, don't get freaked out. Don't get freaked out. Okay, we're going to do this together and everything will be just fine. All right, so we're starting with a times x minus b equals c. We want to get a by itself. Right now it's being multiplied and something's being subtracted from it. So we have to undo that subtraction first because SADMEP, we undo the addition and subtraction first. So we have minus b, which means we need to do the opposite and add b. That looks like a 4. I don't know what happened there. Add b to both sides. Negative b plus b would cancel out, so we're left with a times x on the left, and b plus c, or c plus b on the right. So that's the same first step we did last time, but now we need to get a by itself, not x. So instead of dividing by a this time to get rid of it, we're going to divide by x to cancel the x out, right? Because a is the one we want to isolate. So our answer then, when we solve for a, would be b plus c divided by x equals a. Now you'll notice this is basically the same exact thing as when we solved for x, right? We're just basically switching those two. Okay, so same process, just solving for the different variable there. So here's some notes that may be important that you, I don't know, may want to write down, or maybe you're totally good with this and you're fine. But just to go over a few things, variables are basically just placeholders for numbers. So they have the same properties, right? So to solve those equations with 2 or more variables, we do the same thing as if there was one variable, right? We're going to use the same properties in reasoning. So we're going to use the distributive property, commutative property, associative property, combining like terms, using inverse operations to isolate the variable that we're solving for. Okay, so same exact process and concept as solving for a variable when there's only one variable in the equation versus when there's 2 or more. Okay, same exact process. So hopefully now you won't get a little nervous when you see stuff like this instead of this or whatever that equation was. There was one more important thing I wanted to point out. This will hold, and all of these will apply as long as x is not 0. Okay, so that's one thing I wanted to point out, and that's not always the case, but for this particular example, it is. Okay. I'm pointing that out because some people will try things and they'll be like, but 0 didn't work. I know. Okay, let's do example 1. And I gotta draw you a picture on this one. Lucky you. All right. Lesson 19, example 1. The area of a rectangle is 25 inches squared. The formula for area of a rectangle would be length times width. Okay, here we have a scenario where the width is 10 inches. So I'm going to draw you a little picture. So the width is 10 inches and the length, oh, sorry. Yeah, okay. 10 inches. We don't know the length. That's what we're solving for. Sorry, I totally was reading that incorrectly, even though I just typed this out like a minute ago. It's fine. Okay. So we have a width of 10 inches. We don't know the length, but we do know the area. Okay. So if this is our formula, we want to solve for the length. Essentially, what we're doing is substituting what we do know into the equation and solving for what we don't know. Okay, so we're solving for length in this case. Right now it's being multiplied by 10, so we're going to do what we always do here and divide by 10. Okay, 25 divided by 10 would give us 2.5 inches equals the length. Okay, and you can always check your work, right? If you're like, that doesn't sound right, well, plug it back into the original formula. Okay, 2.5 for the length times 10 for the width does in fact equal 25. Okay, so we're good there. What if we changed it though, so the width was 15? So area is still the same, but width is now 15. How would that change it? Right? How would that change it? Why don't you try that one? Try that one and see what happens. Okay. Let's look at this one now. Rearrange the formula, the area formula, to solve for L. So this time we're not substituting any numbers in. All we're doing is rearranging this formula so it looks like L equals something. Okay, so we're isolating L. Now, if it's being multiplied by W, we're going to do the same thing we did up here when there were numbers. Here we divided by 10 when L was being multiplied by 10. Now L is being multiplied by W, so we're going to divide by W. Okay, that would cancel out the W's because W divided by W would be 1. And 1 times anything is just itself, so we'd be left with L on that side. So L equals the area divided by the width. Okay. So the question is, will solving for L like we did here and using this formula to find the length given the width and the area, will that give us the same length as if we were to just use this formula like we did here? And the answer is yes, right? All we did was rearrange things. We used the same principles to rearrange it as we would if we were solving. Okay. So the key thing to take away from here, sorry, there's a fly flying at my face. Key thing here is that sometimes, not always, definitely not always, solving for the variable, like we did for solving for L over there, for length, sometimes solving for the variable before plugging in any numbers can be easier than after. Okay, especially if you have things like a bunch of fractions or decimals involved, sometimes it's easier to rearrange for the certain variable before plugging in any numbers. So just wanted to point that out because sometimes it is easier, or sometimes it makes more sense to some people than other people. Okay, so again, just to re-emphasize this, rearranging a formula with variables involves the same reasoning and same process, I should say, and same process as solving an equation would be with a single variable. The same rules apply, right? You just may have more than one variable in your answer instead of just a number, right? So I'm going to keep emphasizing that throughout this lesson, okay? Okay, here's where I want you to pause and try exercise 5 by yourself. You have problems A and B, and they both have part 1 and part 2. So try that one and then unpause this to check your work. And I'm going to pause this really quick too. Okay, had to get a drink because my throat was getting dry from doing all these recordings back to back. Okay. Not that you care. All right, so exercise 5. So you should have paused that and gone over it by yourselves, tried it by yourselves. But I'll go over it now just to make sure that we all know what we're doing. Okay. So I'm gonna actually do this over where there's way more space. Okay, way more space. Okay. So let's start with A. Given A equals P times 1 plus RT. We are first, in part 1, going to solve, this is problem A, part 1, going to solve for P. Okay, so we're solving for P. So we want to isolate P on one side of the equation. Right now, P is being multiplied by some quantity. So to get P by itself, we can isolate P by dividing by that quantity. Just as if that quantity were like, if it was A equals P times 2, right? We would divide by 2 on both sides to get rid of the 2, okay? So same concept, it's just a few numbers and letters instead of just one, okay? So if we start with A equals P times 1 plus R times T, we're going to divide by that entire quantity, 1 plus RT. Close parentheses. Because we do that on one side, you have to do it on the other side. So there we go. So our answer then, well, if we have 1 plus RT divided by 1 plus RT, those cancel out. We're left with P on this side. And we have over here, since none of those are like terms, it would stay just like that. That's supposed to be a parenthesis there. So our answer then would be P equals A divided by 1 plus R times T. Okay. Sorry if you can hear my dog drinking water. I swear he doesn't know how to drink water. Like, I swear none of it actually stays in his mouth. He's so messy. Ugh, puppies, right? Okay. Part 2. Jimbo. Jimbo, are you still thirsty? Okay. Well, hopefully it's not too annoying while I write this out. So this time we're going to solve for T. This time we're solving for T. So same formula that we're starting with. A equals P times 1 plus RT. But now we're solving for T. Okay, so we need to isolate this guy. Okay. So, a couple different ways we could do this. But you'll notice that there are these lovely parentheses or force fields around this entire thing. So we can't undo anything inside of the parentheses until we get rid of the parentheses. Okay, so a few things we could do is divide the P, but that would get super messy. Not divide the P, distribute the P. It would get really messy. Okay, but again, just like we did up here, right? we could divide this quantity by the one it's being multiplied by to get rid of it. Okay, so in this case, instead of dividing by 1 plus RT, we want to divide by P. So the P's will cancel out there, which means we can get rid of our parentheses on this side. And now we can get rid of the 1 and the R. Whereas before, they were in that lovely force field where you can't do anything to them until those parentheses are gone. Okay. But now the force field has been taken down and we can get rid of 1 and R. So just like solving any other equation, we're going to get rid of that addition first before the multiplication part. Okay. So we have a positive 1 right now. To get rid of it, we would subtract 1 from both sides. Okay. So over here, that cancels out. We're left with, we're left with R times T on this side. On this side, though, we have the entire quantity A divided by P minus 1, right? We can't subtract 1 from A over P because those are not like terms. You could put it in parentheses if that makes more sense to you. You could put that in parentheses. You could put both of them in parentheses, whatever kind of helps you visualize that they are stuck together. So now we need to get rid of the R because we're solving for T. Right now it's being multiplied, so let's divide. So our answer then is going to be T equals basically this thing right here. That giant mess. We have A divided by P. All of that we're subtracting 1 from, and all of that we're dividing by R. So yes, there is fractions happening inside of fractions, and that's totally fine. Okay, it'd be the same thing as saying like 1/2 minus 1/2, right? It can happen, right? We can simplify it. In this case, we can't simplify it over here because none of them are like terms, right? We have variables that are not the same variable. Okay, so that would give us our answer right there. Hopefully that made sense. If it didn't, let me know. Again, we're just practicing basically rearranging formulas that have multiple variables instead of just one variable and a bunch of numbers. So same thing over on problem B. Problem B for exercise 5. Let's do this. So on this one, we have given K equals 1/2 mv squared. Okay, this formula is, I believe this formula is the formula for, I could be mistaken, but I'm fairly certain it's for kinetic energy. Okay, because it involves, we have velocity. I'm pretty sure that's for mass. Basically what kinetic energy, what this formula is saying that is that the more mass you have and the more velocity you have, the more kinetic energy an object has, or potential for kinetic energy an object has. So think about what's a good example? The Flash. The Flash can absorb. Oh no! Let's think about Black Panther. If you've seen Black Panther, that vibranium suit he has absorbs kinetic energy, right, and then can redisperse that kinetic energy. So it's basically like sucking in the energy when somebody like punches him, right, and then he can redisperse that energy. This has nothing to do with the math lesson, but I'm pretty sure that's what the formula is. So now you at least know what formula we're looking at. It's not just a bunch of letters and numbers. Okay. Nice tangent there, Miss Monson, but let's get back to the lesson. Hey, it's fine though. I don't mind talking about Marvel. Okay, so this first part we are going to solve for m, which in this case, if I'm correct about the formula, is mass. Mass. Okay. All right, so let me rewrite this kinetic energy formula for you. I'm like totally positive it's kinetic energy. In fact, I'm just going to Google this because I want to make sure that I'm correct here and not just like totally embarrassing myself. It is the kinetic energy formula. Sweet. So basically the energy of mass in motion. Cool. All right. Because you guys totally care. Hey, maybe you do. I don't know. All right. In any case, let's solve for m here. So a couple things are happening to m. Right now it's being multiplied by 1/2. It's also being multiplied by velocity squared, or v squared. Okay. So we're going to have to move both of those things over to the other side in order to isolate m. Okay. So let's start with, let's start with, you could do this either way. You could start by moving 1/2 over or the v squared over. I'm going to start by moving the v squared over. So right now, mass is being multiplied by velocity squared. So we're going to divide by velocity squared. Okay. So velocity squared divided by velocity squared would just cancel out. On the other side, we are left with k divided by, or kinetic energy divided by velocity squared equals 1/2 m. My dog just found a squeaky toy. Sorry, guys, I've got a puppy. He's very distracting. Okay. All right, now we have 1/2 m. We need to get rid of that 1/2. A couple different ways you could do it. You can divide by the fraction, right? But we know that dividing by a fraction is the same thing as multiplying by its inverse. So yes, you could divide both sides by 1/2. Totally fine. It'll get you the right answer. But I want you to also recognize that we could simply multiply by 2, right? Because it's the inverse of 1/2. So we're going to multiply both sides by 2. Okay, so the 1/2 and the 2 would cancel out. We're left with mass over here, or m. Now, a whole number times a fraction. Remember, we can put it over 1. Basically, we're just multiplying the top two numbers. So here we would get 2 times k over v squared equals m. And there we go. We just solved for mass. All right, so now if we were given the kinetic energy number of, I don't know, the amount of kinetic energy of a punch taken by Black Panther, and we know the velocity, we can find out the mass behind it. Pretty cool. Pretty cool, though. Just think, next time you watch Black Panther, you'll know a little bit more about what they're talking about when they're discussing the suit and the kinetic energy absorption. Isn't it awesome? I love it. Okay. Let's solve for... I'm getting so distracted here. Sorry, guys. But it's cool when we can actually make these connections, right? That's why we do math, so we can understand the world. All right, so let's solve for v this time. So we're starting with the same kinetic energy formula. 1/2 of mass times velocity squared gives us the kinetic energy amount. And we are solving for v this time. Solving for v, not v squared, but v. So let's start with maybe the opposite step this time. So instead of getting rid of the m, we're going to get rid of the 1/2 first. And again, you could divide by 1/2 and that would be just fine. But in my opinion, it's easier to at least visualize and makes things look a little less messy to just multiply by its inverse. So multiply by 2 instead of divide by 1/2. But either way, we'll get you the same number. Okay, so the 2 and the 1/2 cancel out over here. We're left with m times velocity squared, mass times velocity squared, equals 2 times the kinetic energy amount. I just love it, you guys. Okay. Okay. So we still need to get v by itself. We can't undo the exponent yet because SADMEP, right? And the exponents would come after the multiplication and division is undone. So we need to undo that multiplying by m. Since it's being multiplied by m, we would do the opposite and divide by m. Okay. So on the, that's not what I wanted to do. There we go. So on the left side, we have, again, these are not like terms, so it would stay just the same as that. So 2k divided by m. On the right side, m divided by m would cancel out, so we're left with v squared. All right. Now again, we're solving for v, not v squared, so we're not quite done yet. Not quite done yet. What we need to do now is take, now think about this, what's the opposite of squaring? Well, it's taking the square root. So let's take the square root. Square root of v squared would be v, right? Because v times v is v squared. So again, just a reminder, the square root is basically asking what times what will give us that some number, in this case, velocity squared, right? In this case, it's pretty obvious, right? We just have a variable, so v times v would give us v squared, right? Or if it was 4, right, the square root is asking what times what will give us 4, right? The answer would be 2, right? 2 times 2 is 4. So quick reminder on what square root means. I don't know why I just went on that tangent, but hopefully that helps someone out there. So square root of v squared would be v, and we can't really simplify the square root of 2k divided by m, so that in fact would be our answer. But what you have to remember is that when we take the square root of things, it could be the positive or negative version of it, right? Because 2 times 2 does equal 4, yes, but negative 2 times negative 2 would also equal 4. So it could be the positive or negative version of 2k divided by m. And voila, we have our answer for velocity. How we can find velocity using kinetic energy and mass. Pretty dang cool. Right? So if we had the amount of kinetic energy of a punch that Black Panther took and the mass behind that punch, we could find out the velocity or the speed of that punch. So that's pretty cool. Pretty cool. Okay. So that was exercise 5. Hopefully that helped. Hopefully that was making sense and not me being way too distracting. But hopefully it made a connection. All right. We are going to talk about factoring really quick. Just as a quick reminder, I know I've mentioned it at least once before this year, but factoring is basically the opposite of distributive property. So it's distributing in reverse. So if distributing means multiplying, right, then factoring would basically be the dividing part, right? It's the opposite. So I have an example here of a times b plus c. If we were to distribute that a, right, we're multiplying a times b, which would be ab, and we're multiplying a by c, which would be ac. Factoring would be the opposite. So we're basically starting on this end and getting to this end, right? So basically when we're factoring, we're going to find the common term, right? So if we look at this expression right here, well, the common term would be a. A is in both of those terms, right? So that's the one we would divide by. Okay, so if we divide by a there, we're basically moving a to the outside of the parentheses by dividing, right? We're taking it out of the multiplication. We're doing distributed property in reverse, and we would end up where this one started. Okay, so distributed property, one is basically factoring in reverse, or to rephrase, factoring is distributing in reverse. And to factor, we divide by the common term. Okay, we won't do too much factoring this class, but while we're rearranging formulas, you will see a couple of them on the next example. So I wanted to just mention that really quick. Okay, so let's look at this one. We have a times x plus b equals d minus c times x. Okay, in this one, we are solving for x. Okay, so I'm gonna rewrite this. A times x plus b equals d minus c times x. So the first thing we would want to do, again, we want to isolate whatever variable we're solving for on one side. So we need to move the x terms onto the same side. Okay, so we're going to have to move this whole term to this side. Notice that right now it's being subtracted. So we're going to do the opposite, and we're going to add c times x. Okay. So if we do that, those cancel out, right? Negative cx plus cx would be 0. We're left with d on this side. On the other side, we have a times x plus b plus c times x. Goodness, why isn't that switching colors for me? There we go. Okay, so we want to isolate the x terms, which means we want to get rid of this plus b. Okay, right now it's being added, so we would do the opposite and subtract. Some of you may be like totally ahead of me and like done with this problem already, but hopefully this is helping someone just doing this step by step. All right, so b minus b would be 0. On the left side, we're left with a times x plus c times x. And on the right side, we have d minus b. Again, none of those are like terms, so we can't really combine them, okay? But what you do notice, or hopefully you've noticed, which is why I'm color coding these things, over on the right side, we have a common term, right? The common term being x. Both a and c are being multiplied by x, so we could actually factor x out. So we could divide x out of those two terms, right? So doing that, we would have x times a plus c. And you're like, why are we doing this? This just looks more complicated. Don't worry, we're getting there. We're almost there. Okay, so if that didn't make sense, just notice that here from this step, if we redistributed that x, we would have x times a, which would be ax, and then x times c, which would be cx. So hopefully that makes sense now why we divided by x. Now we can isolate x. Okay, x is being multiplied by some quantity, so we can divide by that quantity on both sides to get x by itself. So, this is getting a little messy, but we get x equals, the a plus x will be canceled out by dividing by a plus x. And on the right side, we are left with d minus b divided by a plus c. And again, we can't make that any more simple than it is because none of those are like terms. So that, in fact, would be our answer. Whew. I know some of you may be thinking this doesn't make any sense. There's so many letters, I can't keep track of things. Just remember, we're using the exact same process in solving for x as we would if all the rest of those were numbers. The only difference is we can't simplify at the end to make it look slightly more pretty, right? It looks a little more messy, but everything else is the same thing. Okay, same process. Same rules apply. Okay, if you have questions after me going through that, let me know. The rest of example 2, I want you to try. So example 2 in your Eureka book is kind of split up in a box, right? We just did the top left one. So I want you guys to do this one and this one and this one, okay? So you're solving 3x plus 4 equals 5 minus 5x, solving that for x. Then you're solving this one for x. And, hold that thought. Okay. All right, and solving that one for x. Okay. That one I do want you guys to, actually, do we want to go over it? Yeah, we'll go over it. So pause the video, try those by yourselves. Please actually do try those by yourselves just so you can see where you're at. And if you have questions without like going through stuff with me, please let me know. If you find out you're totally set on this, you can maybe fast forward me going over it. Okay. All right. So pause the video, do those, and then come back. All right. We are going to do those other 3 examples. So we're going to start with 3x plus 4 equals 6 minus 5x. And I'm going to do these a little faster than the other ones just because hopefully you've done them by yourself, so you're mostly just checking your work. All right, so for this one, we're solving for x. So maybe we'll just highlight where x is here. Okay. All right, so we want to get the x terms on the same side. Now I'm noticing that on the right side, we have minus 5x. Generally, in my opinion, I find it easier to just add the x's instead of subtracting them. So again, it really doesn't matter, but that's generally that's generally my go-to. Okay, so I'm going to add 5x rather than subtracting 3x from both sides. Those will cancel out. We're left with 6 on the right, and 3x plus 5x would give us 8x plus 4. We need to get x by itself. Right now, 4 is being added to it. So we're going to undo that by subtracting, right? The opposite of adding. And we have 8x equals 2. From here, we still want x by itself, so we are going to divide by 8, divide by 8, and there we get x equals 2 over 8. However, we can simplify that fraction. Notice that both of those numbers can be divided by 2. So 2 divided by 2 would give us 1, and 8 divided by 2 would give us 4. So our simplified answer would be x equals 1/4. Whew. Okay. If you have questions on that one, let me know. Let's do the next one. Actually going to just scoot this over so nothing else is distracting us. Okay. I know it's gonna look weird because one's over on the right side and two's over on the left, but it's fine. All right, so the second one was a times x divided by b plus c times x divided by d equals e. This one's slightly tricky. A few ways you could do it. You could notice that both the x terms are being divided by b and d. Okay. So what we could do to get rid of the b and d, right, to simplify that side, would be to multiply by b and d. Now you could do it one at a time, right? Multiply by b first, then multiply by d. You can actually multiply it by them at the same time. Okay. Multiplying by b and d, whether at the same time or by themselves, one after another, will both cancel out the b and the d, just like it would if we had like ax over b by itself and we multiplied by b and those cancel out. Same concept. We're kind of just killing two birds with one stone. Not two real birds, though, two math birds. Sure, okay. Because that also made sense. So those cancel out, but you have to remember to multiply by them on the other side. So on the left side, we are left with a times x plus c times x. I'm just realizing how, well, no, it's not true. I'm not just realizing how weird these videos are, but they are kind of strange. On the right side, we're left with bed, B-E-D. No, they're not in that order on this one, but commuted property says we can reorder however we want, and that's how I felt like reordering it, so there we go. So your answer would be correct if you did B-E-D or B-D-E or E-B-D or E-D-B or any combination of all those letters together. I'm going to use bed, though. Okay. So on the right side, how do we simplify this? Well, we need to get the x's by themselves, right? Right now we have two numbers being multiplied by them. So what we could do here, and hopefully you drew this conclusion, well, this is basically using distributive property to multiply both a and c by x, right? So we could undistribute that x by dividing by x, not c, by x to get this. Okay, right? And if you're like, that doesn't make sense, well, if we redistributed that x, we would have x times a, which is ax, and then x times c, which is cx, right? So that's how we got that. Again, with factoring, you're basically looking for the common term and dividing by that term. The common term there was x, so we divided by x. Okay, and we weren't doing it to both sides because we're not moving the x yet. We were just basically simplifying that side. Okay, or undistributing that side. But now that we have x by itself, we can divide by the other quantity to get x by itself. So we're going to divide by a plus c. Just like if we had 2 times x, we would divide by 2 to get rid of it. Right now there's just two things happening inside the parentheses that we're dividing by. And we just can't combine them because they're not like terms. So hopefully that makes sense as to why we're dividing by both a plus c in parentheses there. Okay, so that'll cancel out. We're left with x on that side. On the right side, we have bed divided by a plus c. And there's our answer. Woo! One more. Again, if you have any questions as I was going through that or after I went through that, just let me know. All right, let's do number 3. We're solving for x. The equation is 2, that's a 2, 2x over 5 plus x. Wait, what am I doing? Okay, 2x over 5 plus x over 7 equals 3. Okay, again, we're solving for x here. Now, before we do anything, notice the similarities between this problem and this problem. Okay, here we have one thing over here, one thing over here. Here we have x being multiplied by something, x being multiplied by something, right? 1. And then both of those terms being divided by something. So this is the same exact thing as what was happening on the last problem, just with numbers instead of all letters. Okay, so we could use the same exact process to solve. Okay, so on the other problem, we multiplied by both D and B down here, right? So if we did the same process on this equation, well, we can multiply by both 5 and 7, right? So if we had 5 times 7 multiplied by this whole jumble of letters and numbers, okay, well, it'd be the same thing as saying 35, right? Because 5 times 7 is 35. So really we're doing 35 times 2x over 5 plus x over 7 equals 3 times 35. Okay, again, it's the same thing as we did last time. Before that was just b and d, so we multiplied by b and d. And if those were like terms, we could have combined them. Since they weren't, it was just bd, right? So hopefully that makes sense as to why we're doing that. Okay, so if we multiplied by 35, again, I've shown you how this works before, so I'm not going to do it explicitly this time. But what happens is these cancel out. Okay, and we're left with 2x plus x. I'm sorry, not 2x plus x. Hello. Actually, yeah, let me show you what happens. So step by step, what happens here? And maybe this will confuse you more. Maybe not. Hopefully not. Basically, I'm just showing you how these cancel out the denominators there. So if we distributed that 35, this is what it would look like. Okay, and we multiply the fraction by the whole number, we'd get 35 times 2. Okay, 35 times 2, so 70. Divided by 5. And 35 times 1 would just be 35. Need more space! Wasn't planning on showing you all the jazz, but we're doing it. We're too far in to go back now. Okay, so now we would simplify by dividing the numbers here. So 70 divided by 5 would give us 14. 35 divided by 7, well, that would give us 5. And then we have our 3 times 35, which would give us 105. Woo! Now what? Well, now you should hopefully notice that these are like terms. They both have x's raised to the first power. We could technically factor out the x like we did with the other problem and do it that way, right? 19 times x. Or we can add them because we know that they're both like terms, so we can add them. 14x plus 5x would be 19x, so we got the same answer. Now we need to get x by itself. Right now it's being multiplied by 19, so let's divide by 19. I know this has been like a lot of letters and numbers today, so hopefully you took a break at some point if you needed it. So our answer then, if we actually divided these, we'd get some crazy decimal. So I'm just going to actually leave it as 105 divided by 19. Okay. If you did want to write it in decimal form, you could round to the nearest 2 decimal places. So it'd be like 5.53. Okay. Woo! That was a lot, you guys. I know. And it was a lot of numbers and letters. And when we threw letters in there, it freaks us out sometimes, but hopefully that made sense a little bit. Okay. So 2 things on today's lesson that you're going to need to turn in. Okay. Both of these you'll turn in next Monday with the drop-off pickup if you are an online student. If you were just absent, you can turn it in class when you get back. Okay, lesson 19 exit ticket. I did print that for you, so it should be in the Monday pickup that you had. Speaking of which, I need to email home about that because I haven't done that yet. So I'm just writing myself a note so I remember. Just being real here. Okay. So there's your exit ticket. It was printed for you, so you can just do it on that piece of paper and then turn it in with the Monday pickup. Or if you weren't able to pick stuff up Monday, or if you were absent or something, you can just do it on a separate piece of paper. That's fine. But basically, you're just solving for I in this inequality. Okay, keep in mind it's an inequality. Okay, so don't forget, if you multiply or divide by a negative, you have to flip the sign. Okay. Okay, when you're done with that, you're going to do the problem set. This is to get more practice because this is really important stuff. Again, the rest of the year is going to be so much easier by getting all of this down really well. Okay, and it's not that many problems. Okay, so problem sets number 1 and 2, 9 through 13, and then number 17. Rep it out, put your name on it, turn it in when you're done. Turn it in with a Monday drop-off. That'd be awesome if you're an online student. Not turn it in when you're back from being absent. Okay, that's it for today. Hopefully I didn't confuse you too much by throwing in so many letters in there. But again, the main point is that we solve those problems using the exact same principles and rules and techniques as we did with when there was numbers instead of letters. Okay? All right. Good luck. Let me know if you have any questions.